This is my beginning algebra course. Today we're going to learn how to factor algebraic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. So we're going to start by factoring out the greatest common factor in these expressions. Now, in a previous class, we multiplied a monomial by a polynomial. Here's an example, and we used the distributive property. 2x times x squared is 2x cubed, and 2x times 5x is 10x squared. So in this class, we're actually going to start here, and we're going to go backwards. When you start here and go backwards, that's called factoring. So factoring is actually the opposite of multiplication. So we're actually going to be dividing. Factoring is actually just dividing. For example, if you have 45 and you change it to 9 times 5, then you had to divide to perform that factorization. So what we're going to do is we're going to factor out the greatest common factor. So we're first going to ask, and I can give you an in-depth explanation of this, but most students really don't care about that. They just want to know, what do I do? And that's really the most important part when it comes to, the most important thing when it comes to algebra is just learning fluency in the language. Once you learn how to do the problems, then you can go back and figure out an in-depth explanation for why it works. But most students never even look back. They just say, you know, I know how to do it, so I can go forward. And that's the way it is with most scientists, engineers, and people in the world. It's only really mathematicians that go back and wonder why it works, and even they don't really do it to a large extent. So we want to ask, what number goes into 28, 8, and 12? What's the biggest number that goes into those? In other words, what number multiplies to these numbers? And the answer is 4. Because 4 times 7 is 28, 4 times 2 is 8, and 4 times 3 is 12. So 4 goes into all those numbers. Then we write an x with the smallest power. This is the smallest power because you have a 5, a 3, and a 2. So 2 is the smallest power, and that's it. That's how you do this. It's very easy. So then, that was called factoring out the greatest common factor. So this is a monomial that we factored out. So now we ask 4 times what number is equal to 28? And of course that's 7. And then we ask x to the second power times x to the what power equals x to the 5th power. I'm going to say that again. X to the second power times x to the what power equals x to the 5th power. So you think about that. If you said x to the 3rd power, you're correct. Because if you multiply these two, you get x to the 5th power. Remember, when you multiply power expressions, you add the powers. So now we ask 4 times what is equal to negative 8? And the answer is obviously negative 2. So again, we're dividing, we're going backwards. Now, x to the second power times x to the what power equals x to the 3rd power. And if you said x, you're correct. 4 times what equals 12? That would be 4 times 3. And x to the second power times x to the what power equals x to the second power. And of course, there would be no x's at all because the power doesn't change. So this is the answer. We factored that polynomial. And if you use the distributive rule to go backwards, if you multiply using the distribution rule, then you'll go back to this expression. So that's what we're going to do for the first part of the day. We actually have 2 things that we're going to do today, so this is the first thing that we're going to do. So let's try another problem. What number goes into 21, 27, and 15? The biggest number that you can think of that goes into all those. The biggest number is, let's see here, I think it is 3. And find the variable with the smallest power, and that would be this y, because it only has one of them. And technically, again, that power is 1, but you don't need to think about that in this course. 3 times what is equal to 21? 3 times 7 is equal to 21. And y times what equals y to the 4th? Well, that would be y to the 3rd, because when you multiply these, you get y to the 4th. And 3 times 9 equals 27. And y times y to the 2nd power equals y to the 3rd power. And 3 times 5 is equal to 15, and there's only one y here, so we don't need any y's on the last term. So that's the answer. So hopefully you're getting the hang of this. If you're not, we'll do a couple more, maybe one more here, and you can try one on your own. So what number goes into 50, 40, and 15? You want the biggest number that goes into all those. Now, by the way, I want to mention real quick here, 2 goes into all these numbers. Isn't that true that 2 goes into all those numbers? But 2 is not the greatest factor. It's not the greatest common factor. 4 is the greatest, so you're always looking for the biggest number. So, for example, here, I think, actually, I can't think of an example of a smaller number, but it's going to be 5. And I'm going to go ahead and factor out the negative 2 because I don't like a negative being on the leading term. So negative 5. You don't really have to factor out the negative, but it's just traditional to make the leading term positive. So we're going to change the leading. Anyway, you don't need to think about that now. So now the smallest power. What is the smallest power on the variables? That would be 3. So now we've factored out the common monomial. We just have to figure out what's left after we factor. So 5 times negative 5 times positive 10 is negative 50. And then we have 3rd power and so on and so forth. Now we have a negative. Again, because we factored out a negative, we have to change the signs. It may not be easy to see that now, but you'll see as we go along here. And then z, and then 5, and it looks like that's going to be our answer. Now again, to check to see if it's correct, you just multiply. You multiply in the opposite direction. And I'm going to go ahead and do that in my head to make sure this is correct. Everything looks correct. Actually, that's not correct. I don't know why I put a 5 there. I'm sorry about that. That should be a 3. And negative 15 z to the 3rd, so that's correct. So that's an important point. You can multiply back to check your work. Do a final check. All right. So why don't you try number 4? See if you can get the hang of this. Pause the video, and when you're done, we'll do it together. All right, we're back. The greatest common factor is going to be 4. X to the 2nd power. So now I'm going to double check, make sure I did that correctly, and it looks correct. So if you got that answer, good job. And again, I didn't really talk about this a lot. I meant to talk about that more, but again, because you're factoring out a negative, the signs are changing here. Hopefully you caught that. I don't know if there's going to be a lot of problems where that's going to happen. Actually, I guess there is going to be some problems because we have one here. So for number 5, you want to factor out a negative. Technically, you don't have to, but we want this coefficient here to be positive. It just makes it it's just more traditional to make the leading term here positive. So try number 5, and when you come back, we'll do it together. All right, we're back. So the greatest common factor is negative 3, y to the 3rd power. Now I'm going to double check that, make sure I did it correctly. So I'm multiplying back in my head. And everything looks correct. So I multiply. I did negative 3y cubed times 4y, and I got negative 12y to the fourth. And I multiplied negative 3y cubed times negative 11, and I got positive 33y to y cubed. Negative 3y cubed times 5y squared, and I got negative 15y to the fifth. So that's how you check your answer to make sure that you did it correctly. All right, on to number 6. Go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. So I'm going to double check my answer here. It's always good to double check your work in Algebraic because there's so much potential to get the wrong answer or to make a mistake. So everything looks correct. So if you got that answer, good job. So again, hopefully you realize here that all we're doing is just dividing. That's what factoring is. So now let's do number 7 together because there's a little something different here because we have two variables. We have a g and an h. So greatest common factor of 6 and 14 would be 2. And we can't do anything with this g because there's no g's on this term over here. So we can't factor out g's from both of those, but we can factor out an h squared. And pretty much just the same type of problem here. So that would be the answer. So again, to see why this is true, you multiply 2h squared times 3h to the fourth, and you get 6h to the sixth, and 2h squared times negative 7g, and you get negative 14h squared g. So again, that's how you check your work. So why don't you try number 8, and actually, you know what, let's try number 8 together. So the greatest common factor of 24, 18, and 36 is, I believe, 6. And now we look at the a's. What is the smallest power of the a's? That's a to the second power here. And not all of them have a's, or excuse me, not all of them have b's. This one doesn't have a b, so we can't factor out b from all of these. So the b's don't really change in this problem. All right, so I'm going to double check that. And I can see I already made a mistake. That's 2 mistakes I've already made. But that's an important point. Again, it's so easy to make a mistake with algebra. You got to go back over and check everything. I don't know why I put a 6 there. And I think everything else looks good. So there you go. We factored out the greatest common factor. So now, why don't you try number 9? And you're going to factor out a negative on this one. Pause the video, and when you come back, we'll do it together. All right, we're back. That looks correct. So if you got that answer, good job. All right, so number 10, let's do together. Number 10 is going to be a little different because we have g's and h's on both of these terms. So let's factor out the greatest common factor of the numbers. That's 6. And then the smallest power on the h's is the second power h. And the smallest power on the g's is the second power of the g's. So you do the same thing that you did in the previous problems, except now we just have 2 variables. And then that would be 2 h to the fourth g. And I just realized that 6 does not work. That's too big. So I think it's going to be I think it's actually going to be 4. So we change this to 3. And that would be 5. So I think that's it. So let's multiply back, see if we get the same answer. And that looks correct. All right, so why don't you try number 11, and when you come back, we'll do it together. All right, we're back. So the greatest common factor looks like it's going to be 7, and a to the second, and b. So let's check our answer. That looks correct. So if you got that answer, good job. All right, try number 12, and when you come back, we'll do it together. All right, we're back. So the greatest common factor of those numbers is going to be, looks like it would be 3. And we have c to the second power is the smallest power of the c's. And then you can see on this last term we don't have an e, so we can't factor out an e from all those terms. All right, so I'm going to double check that, and it looks correct. All right, so we're going to do some bigger ones now, but it's the same principle. So why don't you see if you can do 13. I'm going to write the answer down here because I'm not going to have room over to the right. And when you come back, we'll do it together. All right, we're back. So if you know your multiplication facts, you know that the greatest common factor is going to be 9. And the smallest x is going to be x squared. And the smallest y is going to be y to the second power. And the smallest z is going to be, looks like it's going to be z. And so 9 times 8 is 72, and so on and so forth. And there you go. So now we have to check. So go ahead and multiply back and see if it works. So if you got that answer, good job. So try 14, and when you come back, we'll do it together. All right, we're back. So the greatest common factor looks like it's going to be 7. And the smallest x is going to be x squared. The smallest y is going to be y. And the smallest power of z is going to be, looks like z to the third power. So that's my initial answer. I'm going to go ahead and check that. It looks like that's our final answer. So if you got that answer, good job. All right, we're done with factoring out a common factor there, the greatest common factor. So hopefully you got the hang of that. Again, it's just the opposite of multiplication. You're just dividing. So now we're going to do something very, very special. Probably the most important thing in this course. Something you're going to do over and over and over again as you move up the math sequence. So these are called, well, we know these are trinomials because there's 3 terms, but these are special trinomials. They're called quadratic expressions. So in a previous class, we learned how to multiply 2 binomials. So we used FOIL to multiply 2 binomials. X times x is x squared, x times negative 6 is negative 6x, 2 times x is 2x, and 2 times negative 6 is negative 12. Then we combine the terms to get negative 4x minus 12. So we got x squared minus 4x minus 12. So now what we're going to do is we're going to go backwards. We're going to go from here to here. Now this may seem like it's going to be something difficult, but it's actually fairly easy. So the first thing you have to do is recognize a quadratic expression. A quadratic expression always has a variable with a second power, a variable with a first power, and then no variable at all. That's a quadratic expression. So the first step is to write two pairs of parentheses. The second step is to write an x on each pair because we have x squared. And we're going to ask ourselves, what two numbers multiply to 15 and add up to 8? What two numbers multiply to 15 and add up to 8? So we can try 1 times 15. That works because 1 times 15 is 15. And we can also try 3 times 5. That works because 3 times 5 is 15. And that's it. Those are the only two options. Now we're going to ask, if you add up these two numbers, what do you get? Well, obviously if you add those two up, you get 16. Well, that doesn't work. We want 8. If you add these two numbers up, you get 8. So that's what we want. So it's going to be 3 and 5. Now, if you want to check your work, you just FOIL these back out. So expand the expression. So x times x is x squared. X times 5 is 5x. 3 times x is 3x. And 5 times 3 is 15. And then you add the inner terms together and you get 8x. And you can see that this expression is the same as the original expression. So that's a way to check your work. So the answer is x plus 3 times x plus 5. So this stuff looks difficult, but you can see that it's really not that bad. So now let's try number 16. First step, put your two pairs of parentheses, then put your y on each pair, and then what two numbers multiply to 5 and add up to 6? Now this one's going to be really easy because there's really only one option. 5 is a prime number, so there's only one way to factor it, 5 times 1. And when you add 1 and 5, you get 6. So again, if you multiply 5 and 1, you get 5. And if you add them, you get 6. So it's going to be 1 and 5. Again, if you FOIL that back out and combine like terms, you'll get this expression. So this is factoring quadratic expressions. Let's try another one. Two pairs of parentheses, put your z's. What two numbers multiply to 12? Well, I know it's going to be 3 and 4, because 3 times 4 is 12, and 3 plus 4 is 7. So that's the answer. So now, why don't you try number 18? But just be aware that there's actually going to be 3 possible factorizations of 12. So, again, what two numbers multiply to 12 and add up to 8? So go ahead and attempt number 18, and when you come back, we'll do it together. All right, we're back. Now, I'm going to try 1 times 12, because 1 times 12 is 12, but if you add them up, you get 13. That doesn't work. Now I'm going to try 3 times 4. I know it's not going to be 3 times 4, because that one would produce 7. So that's not going to work, because 3 plus 4 is 7. What about 2 times 6? 2 times 6 is 12, and when you add 2 and 6, you get 8. So that's the answer. So if you got x plus 2 and x plus 6, good job. Again, we're multiplying these. X plus 2 times x plus 6. So why don't you try number 19, and when you come back, we'll do it together. All right, we're back. So what two numbers multiply to 4 and add up to 4? Well, you can try 1 times 4, and you can try 2 times 2. If you add these, you get 5. We don't want 5, we want 2. Or excuse me, we want 4. So, but if you add 2 and 2, then you get 4. So in this case, the two numbers are actually going to be the same. So if you got y plus 2 times y plus 2, good job. All right, so try number 20. When you come back, we'll do it together. All right, we're back. So it's going to be 6 and 3. So if you got that answer, good job. Now try 21, and when you come back, we'll do it together. All right, we're back. There's only one option. It's got to be 3 and 1. So if you got that answer, good job. All right, try 22, and when you come back, we'll do it together. All right, we're back. So there's only one possibility, 1 times 1. So it's got to be 1 and 1. Again, if you don't believe me, you can FOIL that back out, and you'll see that it ends up being this expression when you expand and simplify. So now try 23, and when you come back, we'll do it together. All right, we're back. So I know, let's see, 1 times 27 doesn't work because 1 plus 27 is 28. And I think there's only one other possibility, and that's 3 times 9. 3 plus 9 is 12, so that works. So if you got 3 and 9, good job. All right, try 24, and when you come back, we'll do it together. All right, we're back. So you're really going to have to know your multiplication facts for this one, because 1 times 72 is not going to work. 2 times 36, that's not going to work. 3 times, would 3 times 18 work? No, that doesn't work. We're going to need a bigger number. I think it would be 3 times 24, but again, you don't really need to do all this. That's a lot of hard math. If you know your multiplication facts, you can try 8 times 9. You know 8 times 9 is 72. And of course 8 plus 9 is 17, so that works. So that was a harder one because there's a lot of factorization options for 72. So try 25. And again, this is a more difficult one because there's a lot of possible factor options for 56. Try 25, and when you come back, we'll do it together. All right, we're back. So put your Z's. And 56, I know it's going to be 7 times 8. That's the first one you should try because that's the easiest one. 8 plus 7 is 15. All right, so now we're going to something a little bit more difficult because now we have a negative sign. In all the problems we did before, we had all positive numbers. But the process is still the same. What two numbers multiply to negative 10 and add up to 3? Again, the only difference is now we have a negative number here. So we can try negative 1 times 10, or we can try positive 1 times negative 10. And we can try, I don't really need that dot there if I'm going to put parentheses, but you get the point. We can try 2 times 5, negative 2 times 5, or positive 2 times negative 5, and so on and so forth. So those are the options. So now we have to ask which one of these, when you add it up, we add those two numbers up, you get positive 3. And obviously the answer is negative 2 times 5. If you add negative 2 and 5, you get positive 3. So we have Z minus 2 and Z plus 5. Again, if you multiply 5 and negative 2, you get negative 10. And if you add those, if you add negative 2 and 5, you get positive 3. So that's how we know that we did it correctly. And I just realized that I'm not rectangling these. Let's get those rectangled. So why don't you try number 27? And again, if you have a negative on this number, that means that one number is going to be positive and the other one's going to be negative if you have a negative in the last term of the trinomial. So try 27, and when you come back, we'll do it together. All right, we're back. So again, there's a lot of different options, but I'm going to make this stuff pretty easy for you. I'm not gonna give you a problem where it's 1 times 28 or 2 times 14 because that's where it gets really difficult. I'm just going to give you easy ones. So 28 we know is 4 times 7, and that's going to be the answer. But we have to figure out which one is negative. One of these has to be negative. So let's try 4. Let's make 4 negative. So that works. Negative 4 times 7 is negative 28. But when you add them together, negative 4 plus 7, that would be positive 3. We have a negative 3. So that all that means is that you have to switch the signs. It's got to be a positive 4 and a negative 7. So if you got that answer, good job. All right, so for 28 we have something different because now the negative is on a different number. It's in the middle number. It's not on the ending number. So what that means is that the two numbers, if they multiply to a positive, then when you and they add to a negative, that means the numbers have to both be negative. And I'm going to try 6 and 9 because I know 6 times 9 is 54. So we'll try negative 6 and negative 9. And then when you add negative 6 and negative 9, you get negative 15. So that must be correct. So why don't you try another one of those? Let me find one where there's a negative in the middle and a positive in the positive on the end. So why don't you try 35, and when you come back, we'll do it together. All right, we're back. So I know 3 times 5 works. So put your negatives, and then negative 3 plus negative 5 is negative 8, so that works. So if you got that answer, good job. So that's how that type of problem works. But here we have a problem where we're going back to negatives, so I think you get the point. It's all the same principle. It's just a negative times what two numbers multiply to negative 44 and add up to negative 7. So there's going to be a lot of different variations, but you can just try your best to figure out what those two numbers would be. So try 29, and when you come back, we'll do it together. All right, we're back. Put your pairs of parentheses, your z's. And let's see here, 44. I think that's going to be 4 times 11. And I know one has to be negative and one has to be positive because it's a negative 44. And when you add them up, you should get a negative 7, and it looks like that's going to be the answer. Negative 11 plus 4 is negative 7. All right, try number 30, and when you come back, we'll do it together. Now, number 30 has no negative, so this should be pretty easy. All right, we're back. That's going to be 2 and 3. So if you got that answer, good job. Looks like 31 is another problem where there's no negative, so that's going to be easy. Let's go ahead and attempt 31, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. Try 32. We have a negative here, so it's going to be a little bit more difficult. And when you come back, we'll do it together. All right, we're back. And by the way, make sure you put these equal signs. You got to use complete sentences when you're writing math language. Let's see here. That's going to be positive 7 and negative 3. And by the way, you're probably wondering, does it matter what side you put the numbers? Can I put the 7 over here and the negative 3 over here? And the answer is absolutely yes. That's completely fine. It's fine when these are both z's, but if you have a coefficient in front of one of these z's, then you can't just switch those around. But we haven't gotten to those types of problems yet. We'll get to those later. Try 33, and when you come back, we'll do it together. All right, we're back. So if you got that answer, good job. I think that was actually a repeat of a problem we already did, if I remember correctly. But it's still good practice. All right, try 34, and when you come back, we'll do it together. All right. I think it's going to be negative 10 and positive 5. So if you got that answer, good job. Try number 36, and when you come back, we'll do it together. All right, we're back. Let's see. All right, looks like this is going to be 3 and 10. Negative 3 and 10, I mean. So if you got that answer, good job. All right, try 37, and when you come back, we'll do it together. All right, we're back. We're going to have the same factors, z minus 6 times z minus 6. So if you got that answer, good job. Try 38, and when you come back, we'll do it together. All right, we're back. Looks like it's going to be negative 9 and positive 1. So if you got that answer, you're on the right track. Try 39, and when you come back, we'll do it together. All right. If you got 5 and 6, good job. Try number 40, and when you come back, we'll do it together. All right. If you got, this one's kind of a tricky one. Looks like it's going to be plus 20 and minus 1. So that was a tricky one. Usually it's not going to be those big numbers. But every once in a while you'll get something like that, and you'll just have to keep trying options until you find the answer. All right, try 41, and when you come back, we'll do it together. All right, it's going to be, looks like it's going to be 12 and 2. So that's not one of our multiplication facts. But, you know, sometimes you're going to encounter problems where you got to multiply bigger numbers. So if you got that answer, good job. Try 42. Now 42 is going to be a little weird because this is, you know, what number is here? There is no number. Well, again, if you have a negative x, the coefficient is assumed to be negative 1x. So pretend that that's negative 1. So what two numbers multiply to negative 12 and add up to negative 1? Attempt that problem, and when you come back, we'll do it together. All right, we're back. And we have negative 4 and positive 3. So if you got that answer, good job. Try 43, and when you come back, we'll do it together. All right, we're back. Looks like it's going to be negative 5 and negative 5. Those are called repeating factors when they're the same. So if you got that answer, good job. Try 44, and when you come back, we'll do it together. All right, we're back. Let's see, I think that's going to be 7 and negative 1. So if you got that answer, good job. Now 45 looks like it's going to be a challenge problem because look at this number. It's pretty big. So you might want to get your calculator out, and that'll help you. Try dividing 80 by 2. Try dividing it by 4. And maybe try 5. 5 times something is 80. And when you come back, we'll do this problem together. All right, we're back. So I have a feeling it's going to be 5. Let's see, 5 times 18. That would be 80. Actually, no, that's not 80. 5 times 16. That would be 80. So 5 times 16, is that going to work? I don't think that's going to work. So 5 times 16 did not work. But what about 4 times 20? 4 times 20 is 80. So let's try 4 and 20. And obviously, if you add 4 and 20, you get 24, so that's it. So if you got that answer, good job. That was a challenge problem. All right, attempt 46, and when you come back, we'll do it together. All right, we're back. And think it's going to be 5 and 8. So if you got that answer, good job. All right, so now we're going to something different, much different. All the problems that we did are fairly easy if you know your multiplication facts. If you don't know your multiplication facts, you're in some big trouble, because your math journey from here on is not going to be easy. In fact, your math journey probably wasn't easy in the last couple months if you didn't learn your multiplication facts. This next problem is not going to be as easy as the problems we just did. So let me show you what I mean. And the reason it's not going to be as easy is because this number right here. Notice that on all these problems, the coefficient of these first terms was just 1. Right? But here we have 2y squared. So that complicates things. It makes it to where our method for factoring is not going to work. So we cannot ask what two numbers multiply to this and add up to this and get the answer. It's not going to work. So what we have to do is we have to consider this number as a product and this number as a product. So first, the first part is the same as the problems we did. We're just going to ask what two numbers multiply to 3. And we know it's got to be 1 and 3. But we also have to ask what two numbers multiply to 2. That's the difference. And instead of putting a y and a y, we put a y and a 2y. Because y times 2y is 2y squared. Remember, if you foil these back, you're going to get, you should get this expression. So we have positives, they're all positives, so I know that these are going to be positives. So again, because the first two terms multiply to 2y squared, we put y and 2y, and the last terms multiply to 3. So now we have to figure out if when we perform FOIL, we get this number, this 7y. So in order to do that, we actually have to use FOIL this time. We can't really get around it. So I'm now going to use FOIL. So y times 2y is 2y squared, of course. That's the way we designed it. And then y times 3 is 3y. And then y times 2y is 2y. And 1 times 3 is 3. So when you add those together, you get 2y squared plus 5y plus 3. We didn't get the right number. All right? So we have to try something different. So again, I just want to mention the reason that it doesn't we can't just use the same method is because this makes it to where the numbers are not going to add up to 7. And I could go into a lengthy explanation of that, but I don't want to waste your time. I'm just going to show you how to do it, and you just got to learn it. So now the only thing that we can do is we can switch these numbers. I mean, that's the only possibility. So I'm going to go ahead and take the 1 and put it over here, and the 3 and put it here. So now if we FOIL out, we get, of course, 2y squared, but y, and then we get 6y. And 3. So again, y times 2y is 2y squared. Y times 1 is y. 3 times 2y is 6y. And 3 times 1 is 3. So now when we add the inner terms, we get what we're looking for, 7y. So we know that that must be the correct factorization. So as you can see, these problems are much more difficult than the previous quadratic expressions when it comes to factoring them. So I'm not going to make you do a lot of these problems because they're kind of annoying, but we will do some here. So let's do a couple together before you try one on your own. So we know it has to be 3x and x because these multiply to 3x squared. Again, you're just going to put your x's just like you did before, but now you have to have a 3 on one of them because we have a 3 there. 3 times 1, and again, there's no coefficient in front of that x, but it's assumed to be 1. So 1 times 3 is 3, so that's why we put 3x and x. What two numbers multiply to negative 4? Well, we got problems because it can be negative 2 times 2, or it can be negative 1 times 4. We don't know. So we have to try. So I'm going to try negative 2 and positive 2. And if we FOIL that out, we get 3x squared plus 6x minus 2x minus 4. And if we combine the inner terms, we get 4x. It doesn't work. So we tried that one and it didn't work. But before we get rid of the 2's, before we try the other factorization, what you want to do is switch the sign. So make this a positive. I guess I didn't have to erase the 2's. So we're switching the signs, and we'll try. Actually, no, that's not going to work. That's actually just going to give us the same answer. If we switch the signs, we're just going to get the same answer because these two numbers are the same. So it turns out that the 2's and the 2's aren't going to work. So the only other option is 1 and 4. But we don't know if the 1 goes here or here. So again, FOIL it out. So 3x squared and 12x and negative x and negative 4. And when you combine these, 12x minus x is 11x. So that's not 1x. It didn't work. So now we have to switch the numbers. We have to put the 4 on the other side, or on the other pair. So now let's try it. 3x squared plus 3x, and I'm using FOIL. It's all about FOIL. Now when we combine the inner terms, we get negative x. That's exactly what we're looking for. Except they want a positive x. So we got the right number. We got 1. Because again, remember, the coefficient is always 1 if you don't see it there. We got 1, but we didn't get the right sign. But that's okay, because all that means is that we have to just change the sign. We have to change this one to positive, and we have to change this one to a negative. And that is the answer. So if you FOIL that out, you get the expression over here. So we'll try a couple more of these together. I'm going to start going a little faster now. I don't want to bore you. So we have 5z and z, and it's got to be negative 1 and negative 1. So this one was actually pretty easy. There's no other options for this one. If you switch, you just get the switch numbers or switch signs, you just get the same thing. It's not signs, but you get the point. All right, so on to number 50. So we have 2y and y, and then we have, let's try 2 and 3. Now we're going to FOIL it out. 2y squared plus 6y plus 2y plus 6. Add these together and you get 8y, so that didn't work. But before you get rid of the 3 and the 2 and try something else, first try switching the 3 and the 2. So we're going to put the 3 here and the 2 here, and now let's try. So FOIL it out and you get 2y squared plus 4y plus 3y, and it looks like we got lucky because now we have 7y. You add those up and you get 7y. So that is the proper factorization of that trinomial expression. All right, so if you want to, I know this is kind of involved, but if you want to, you can go ahead and try the next problem, and when you come back, we'll do it together. All right, we're back. So it has to be 3x and x, and I'm going to try negative 2 and positive 4. So looks like that is not going to work. So I'm going to switch these around, and looks like that is going to work. And so that would be the answer. So if you got that answer, good job. All right, try number 52, and when you come back, we'll do it together. All right, we're back. So we need 2y and y. because we have the 2 there, and 15 I'm going to try 5 and 3. So plus 5 and negative 3, let's see if that works. And that does not work, so I'm going to try to switch the numbers. I'm going to put the 5 over here and the 3 over here, and looks like that is going to work. So if you got that answer, good job. Now you might have to try 2 or 3 or 4 different options before you get the right answer, and that's why these problems are kind of annoying. So try 53. When you come back, we'll do it together. All right, we're back. Let's see. I'm going to try negative 2 and positive 2. And it looks like I got lucky on that one. That looks correct. So if you got that answer, good job. All right, so for 54, things are going to be more difficult because you have multiple options for factoring 6. So what that means is you can put 3z times 2z, because 3z times 2z is 6z squared. But you can also put z times 6z, because 1 times 6 is 6. So we don't know which one it's going to be, but I have a feeling it's going to be 2z times 3z, because that's more common for me to write those types of problems. All right, so for 28, I'm going to try 4 and 7. 4 times negative 4 times 7 is negative 28. And then I'm going to go ahead and FOIL those out. And let's see. It looks like that is going to, let's see. Looks like that's going to work, but we're going to end up with positive 13. So we need negative 13, so we just have to change those signs. So again, that was a harder problem because you not only had to try different options for this product, but you have to try different options for that product. All right, so let's try the next one here. So again, we have 4, so there's 2 options. You can try 4y and y. They multiply to 4y squared, or you can try 2y and 2y. They multiply to 4y squared. Now I know that these both have to be negative, so I'm going to try negative 5 and negative 3. And let's see, the inner terms would add up to negative 16y. And I'm just doing this in my head. I mean, hopefully you've got the idea by now. If you don't, you can just look to my previous problems there. Maybe I should just go ahead and do it. So using FOIL, we have 4y squared and negative 10y and negative 6y and plus 15. So these inner terms add up to negative 16. We don't want negative 16. We want negative 17. So let's see. Now, if we switch these numbers, negative 3 and negative 5, we're just going to get the same answer because these 2 terms are the same. So that probably means that we need to write 4y and y rather than 2y and 2y. Let's see, negative 4y squared, negative 20y minus 3y is negative 23y. So that doesn't work. So we can try switching these numbers. Let's try putting the negative 5 here and the negative 3 here. Then we get, in the inner terms, negative 12 and negative 5 is negative 17. So it looks like that's going to be it. Now notice I'm doing that in my head. I don't want to bore you by writing out every single option here. When you get used to these problems, you're going to start to do this stuff in your head, so it's going to go a lot faster. So if you're depressed because you're thinking, man, this stuff takes a lot of effort and work, well, once you get used to these problems, it's going to go a lot faster. All right, so 56, we have 3x and x, and you should probably attempt this problem on your own, so pause the video, see what you can do. All right, so you should have your answer, and let's try plus 1 and plus 3, and we get, looks like that's going to work. So if that was your answer, good job. So let's see here. Why don't you try 57? 57 is going to be easier than these other problems because, again, there's only one option for the factorization of all these, actually, 5, 7, and 11. So try 57. When you come back, we'll do it together. All right, we're back. That's not going to work, so I'm going to have to switch the 4 and the 2. And looks like that's going to be it. So at this point, you're probably starting to realize that when you check these, you don't have to use the F and the L of FOIL. You don't have to use that part because you know it's going to work based on the way that you set it up. So all you really have to check is O and I of FOIL. So try 58, and when you come back, we'll do it together. All right, we're back. So 7y and y, and we'll try -5 and -1. So if I do O and I of FOIL, I get -12. Looks like I got lucky. I got the answer in the first try. So if you got that answer, good job. Try number 59, and when you come back, we'll do it together. All right, we're back. 11 is prime, so it's got to be 11x times x. And there's two options for the other two numbers. I'm going to just try 2 times 2, that's 4. So now, again, if we do FOIL, we don't have to do F and L of FOIL. We only have to do O and the I. So outsides multiply, we get 22x, and the insides we multiply, we get 2x. Add those together, you get 24x, so obviously that doesn't work. So it can't be 2 and 2, so it's got to be, and you know, if you switch the 2's, obviously that's not going to make any difference because they're both the same. So you're going to change those 2's to a 4 and a 1. Now we don't know if the 4 goes here or here, so we're going to have to check this. Now again, if you do FOIL, you don't have to do the first terms because you know the first terms are going to work. That's how we set it up. But you can do O and you can do I. And you don't have to do L because, again, we know L works. We know 1 times 4 is 4. All right, so if you add up 11x and 4x, you get 15x. So obviously that's not the correct answer because we need 45. So all that means is we just have to switch. We just have to put the 4 over here and the 1 over here. So now if we do the O and I of FOIL, we get 44x is O, the outside terms, and multiplying the outside terms. And the inside terms we multiply, we get x, and when you add those up, you get 45x. So that means that that is the correct factorization. So if you got that answer, good job. So that was the lesson today. We learned how to factor out a greatest common factor. We factored out a monomial term from all these polynomials. And we learned how to factor a quadratic expression when the coefficient was 1 in front of the variable. And we learned the more tedious problems where the coefficient is not 1 in front of the variables. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Now don't go before you get screenshots of your homework. Here's the first 2 pages, get a screenshot of that. And get a screenshot of the answers. Now remember, your homework has to have 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. Now I know that this stuff seems really weird, but this is the foundation of much of what we're going to do in this course. You must have a solid understanding of what we did today. So be sure to get all these homework problems done, and I'll look forward to seeing you in the next class.